Pay attention, guys. Aloha.
Aloha.
The teacher's already here and you guys are talking. Alright. So,
Sorry, teacher.
it's alright, it's alright. I won't deduct your grades. So. Participation is important. So, before we begin class, I want to spend a little time with you and get to know each other a little bit. You know? We're gonna tell a story, not a story, but we're gonna share our favorite food. You know? So we're gonna think about our favorite food, and I want you to think of the reason why your food is delicious or you like it. You know. So I'm pretty sure everyone will has something in mind. All right. So you all got yours in your mind now. Would you like to share?
I love eating fish and lobster. Mostly seafood. Lobster.
So why do you like it? Why you love it? You said you love it.
It's my father's fisherman.
Oh.
And I live close to the ocean.
Wow.
So when you cook it, you just cook it straight, or?
But fish I can eat it raw with
Eat that raw?
Oh, you did raw.
Oh,
Oh, that's very good. Yeah. It's good for you, but it's a little bit scary. Yeah.
I love it actually.
and the lobster. The lobster I can just boil it.
Wow,
Boil it?
lobster's so good.
Are they alive when you boil it?
Yeah.
Is it? Are they expensive there? Are they expensive there? Oh, is it expensive?
I don't know, my dad.
It's free.
My dad.
Just go out in the ocean and get them.
Oh, it's free.
Thank you very much, Indon. Well, we have another minute, so does anyone want to share favorite food?
My favorite
Oh,
food
yeah.
is sausage. I don't know, I just like to eat sausage. Like, I wish I could go to Germany to eat different kinds.
Oh, my word.
How you cook it?
Like pineapple
Fried
sausage.
it.
You fry it? You,
Yeah,
you
I
fry it
think
with what?
different kind.
What? Did you mix it with something?
Like, just sausage is good.
Oh,
No matter how am I gonna mix it with different other
Alright.
ingredients. Yeah.
so it's right here. So when we think about sausage, you know,
Oh, my word.
it doesn't come straight from the meat itself. It
Yeah,
is mixed with something,
processed
right?
food.
So if we come to think about that, oh, that makes it maybe delicious, you know, the way you like it.
Yeah.
So yeah, that's right. All right, so these are the outcomes. We're gonna. The topic is a chemical reaction, but these are the outcomes that I have three. So the first one.
Student.
1, 2, 3. Yeah. Would you like to? Yeah. You're so.
Student can define chemical reaction and name its 3 critical attributes.
Students can distinguish the difference between chemical reaction and physical reaction.
Students can analyze their own level of thinking by answering to reflective questions that will be given to them.
All right. So from here, it says we're gonna go through some examples, some critical attributes. You know. Chemical reaction is a concept. And so the definition is right here. I tried to make it very simple, you know, very short. And when I first, read it, I wasn't sure, still wasn't sure. Because, here it says, it's a process that leads to the transformation of one set of chemical substance to another. So this is basically a scientific definition, right? And it's talking about something changing to a different thing, all right? One set of chemical substance. Well, chemical substance is things that makes up that one object, we can call it an object, and then it changes to another. Alright, so that's the definition right now. Well, yeah, I forgot to give you the, got a graphic organizer right here, and you know, I'll just have it in front of you, and as you go along, make sure you you write down the definition and you know, something like that. What's that? You have a question, Tom? Yeah, you gotta put it the other way around. So on the paper, draw a line like this. Guys got it?
The back.
Yeah. Write a plus here and a minus. See, we just created our own graphic organizer. All right. Attribute. On the left side, critical attributes, and on the right side, non-critical attributes. Right, so I hope you have your own, you have written your own definition of the chemical reaction. But here, we're going to see the differences, right? So these are the attributes of a chemical reaction, and these are the non-critical attribute. So the first one, form new substance. Emily, can you read the second one?
Change color.
Change color. Delta?
Energy transfer. Heat or light.
All right.
Gas produced.
Gas produce. Dawn? Temperature change. Oh, it's all right. So you speak English as your first language. Now we are learning All right. So what I want to try to point out here is these two words: chemical reaction and physical reaction. You know. Well, last time we learned about physical reaction. You know, there's no change. But here we are learning about chemical reaction that, you know, you can do it, right?
Could you add for critical attributes 2 or more substances mixed together?
Yeah, you can have that one.
It doesn't just change by itself, it has to be mixed.
It has
with
to be
something,
mixed.
right?
Yeah, that's right. That's one of the critical attributes. Yeah, that's right.
Mixed.
What do you mean by gas produced? I'm wondering that.
Gas produced. All right. So let's talk a little bit about this one. Gas produced.
Hmm?
Yeah. That's it.
Can it be like from the soda? Where you mix and then there's gas inside?
Yeah, that's gas. You know. Yeah.
Like that?
Yeah. It's a form of liquid. It's a different form of liquid. So.
Yeah, but that's not, does that happen every single,
That it only happens when you mix two things, and then, like what I said, you know, two substances mixed together, and then when there's a gas produced, that's chemical reaction.
yeah, but can gas be produced from something else?
Right now, I'm you think about something else besides chemical reaction?
Well, I'm just wondering if it's a critical attribute or non-critical attribute, because if gas can be produced by something else, then it would be a non-critical attribute.
Yeah, I was thinking like nothing else besides chemical reaction. So that's why it's in the line of critical attributes.
Good.
So, yeah, on your piece of paper, let's go the left side, it's a plus side where you're gonna input your critical attribute. And then the right side, non-critical attribute. All right.
Whoa.
Now we're gonna name the examples. But I'm sorry about that. So keep in mind that these are the things that will help you to know, chemical reaction, to recognize it, before, because the next slide is gonna be talking about examples. And then from here, it's gonna help us more to, to understand the examples that we're gonna be talking about later on. All right, it's pretty good, huh? Examples and non-examples. Photosynthesis, combustion, rust, digestion, salt, and how to pronounce that one?
Detergent.
Digestion.
Detergent.
Detergent.
Cleaning, something that cleans.
That's right. I'm a science teacher, so pronunciation is an issue.
You'll get it.
All right. So, well, it's kind of interesting, now that you see these examples, now you can, oh, that's right. Photosynthesis, like what we talked before, earlier, there's a gas produced right there, right? From liquid to gas. So that's photosynthesis right there. Combustion,
Oh.
You see? Interesting, huh? And rust,
Oh, yeah.
Think about rust, the metal mixing with what you call it, salt, yeah, in the form of salt, but also it can be mixed with the hair, the kind of hair. That's the salt, yeah, that's and then they mix together and then they form rust.
Or any kind of water, I guess.
Yeah, acid rain.
You know?
Can do that too.
Even digestion, look at it, You eat the food now, it's digested, comes out, different thing, right? Well, it's different thing, But when your body uses it up and you break it down and, different different things, You get vitamin from it, you get, other minerals. So now we're getting the point where, we can look around, this is this and this is this. Non-example. Melting an ice cube. See? Well, here, you can melt, the ice, you melt it into a liquid, and then you can put it back. It's like, it doesn't really form a different
But still.
form, still, right?
But
It
it's still a
changes.
change, right?
It doesn't change.
The
It
shape
doesn't
it
change
does.
the, what it is.
Yeah, what it is still
It changes shape.
Oh.
But it
But
doesn't
it's
change water, it's
Okay.
water, it's H2O, whether it's frozen or liquid.
Remember the non-critical attribute? It only
Yes.
change form, size, but not the, not the what? Not the form, right?
It doesn't change
The object.
to something else.
Something else.
Something different.
Just the shape.
Yeah. Oh, this is interesting. Like mixing sand and water. It's nothing. You can just like, separate it and, it doesn't,
Yeah, but it takes.
it cannot mix together.
Yeah, if you mix sand and water, then what you get is sand and water.
Sand and water, still.
But
So
if you
no-
mix water, sunlight, and carbon dioxide, you mix those three together, you get something completely different called oxygen. See how it's all
But
different?
what
That's
is,
right. That's chemical reaction. Yeah.
what was the chemical that mixed with those that it's the result that
What is it?
the brick?
The brick.
Yeah, sand,
Sand.
sand,
Water.
water, and cement.
Oh,
But when you, no matter, it's still sand, water, and cement, it's just a different form. Right?
solid.
It's a solid, but it's still sand, water, and cement. It's not something totally different,
Yeah.
right?
If you break down the brick, you still can get the sand out of it. You know what I mean?
But no water.
You're not
But no
all
water.
the water.
Okay.
Well, I think we are already there, right? That's it. That's the concept right there, chemical reaction. And again, I want to point out again that, yeah. Physical reaction, chemical reaction, that's the best way to differentiate, If you are like a little bit confused, this is the very best way. Oh, there's a physical reaction, there's a chemical reaction. Just put it that way and you'll be fine. I just provide a video, it's just gonna show more of the chemical reaction that maybe we didn't talk about, But it's gonna be based more on chemistry concept, I mean, the ones that they actually do it in the lab. chemical reaction, huh? Now it's getting like interesting, more interesting, huh? You can look around, you can see the table. This thing is like, things made of chemical reaction. It's
Yeah.
expensive, you know? You're wearing the clothes, man. Chemical reaction. Something else is mixing.
Yes.
Look at this cloth. So now I want you to name 3 examples of chemical reaction. Your own example. But guess what? We're gonna work in groups, huh? You're gonna help your sister here, and she's gonna help you. And you help each other out. So name your own 3 chemical reactions and then say it to each other. And I'm gonna go around and make sure that you guys are picking the right examples, huh?
Yeah. So to me, like when you cut an apple, even though you don't change the shape, but the air actually makes it kind of brown. Yeah, change the color. And
Like avocado, once you cut it.
yeah. That's why it's growing.
I wonder if mold is a chemical reaction.
Mold?
Like water mixes with something to grow green.
Yeah.
mold.
Because like it's come from nothing.
Yeah.
It starts to grow.
What is
Bacteria.
that?
Is that the bacteria start to grow?
Okay.
The human cake, like you mixed, but they're not chemical?
Photosynthesis.
Go ahead and list down your 3 things and
Oh.
3 things and then.
I don't have it.
What you got?
Our examples of like an apple, like a cut apple, you leave it out long enough, it turns brown.
Yeah, the air and the apple actually making some,
So what is mixing in here?
the air,
Apple and air?
the acid in the apple.
Yeah.
And what's it changing into?
Yeah.
The brown color.
The color is not is a non-critical characteristic. Is the brown still the apple, just a different color?
You cut the apple and then they get pushed.
I know it gets brown and rotten,
So.
but is it still the apple or is there something different?
Yeah, right.
So like packets of lemonade, you like put it in a water bottle and you like mix it. Like you take the powder and water and it makes lemonade.
Yeah.
That works.
Ah,
Is it?
I don't think so because then you just have water and lemonade mixed together.
How about cooking?
See, what we're getting is something completely different than what you mix together.
Yeah.
So if you mix chemicals together, you can make plastic.
Oh.
So whatever chemicals mixed together are different than the actual plastic it produces, right? Right? So what we're trying to do is find certain things that create out of those something completely different. It doesn't have those same properties or same thing.
Because I was asking Brent if baking a cake is an example of that.
How about sausage?
I don't know. I think a cake
Because you
is
just,
still flour, sugar,
But you put
water,
soda.
oil.
Baking soda.
It's just, it's a different form. But form is not a critical characteristic.
okay, oh, okay.
Like if you mix water, sugar, flour, and if you mix that together and you got a piece of plastic, that would be a chemical reaction because it's completely different than what got mixed together.
Oh yeah, and I forgot to mention, also another critical attribute is you cannot reverse it.
Yeah.
You cannot
Go back.
go back, so, you
Cake
know,
and-
Oh, so,
Cake you go
yeah,
so you could take a cake and go back to the
Yeah.
ingredients.
which is, that means it's not really a chemical reaction, right? You still can like, you know,
I think you cannot, after you bake a cake, you cannot break it down
Yeah,
into
you cannot
powder
take the
and
egg.
baking soda and then other stuff.
Well, but I think, maybe not. What about paper? What about paper?
Paper is made out of the.
Yeah,
the
it can
sugar.
go,
Made out of
you
wood.
burn it, and then it just become black.
You know what, paper is a good, it's a good example of chemical reaction. I've watched the video on how they create the paper money.
Oh,
So, they take the wood skin, the wood, from the tree, and then they had it with a lot of
What
acid,
kind of trees?
and then,
Pine
well, they
tree?
had it together in a big machine. And so they put chemicals like, I forgot that, maybe calcium, something like that.
yeah.
And they mix it together and then turns out it's like a different form of paper. It's just a different thing. Not a wood anymore. It's just like, But I know a chemical reaction is a concept, like a pretty deep concept. Sometimes you can think of easy examples. Sometimes it's a little bit like, we have to make sure that you know what is that,
How about the
Chemical reaction.
But
medicines?
Yeah,
medicine, that's a chemical reaction.
I got one.
a core of the tree.
What about flesh?
Flesh.
Skin. Mixed together with something to make skin, right?
Sorry.
Yeah. Or
Skin or body?
You grow,
Anything. I
right?
mean,
We eat and then we grow.
I'm just
Baby.
saying, what is skin made out of? They say our bodies are made out of water,
So,
Oh, really?
Sand.
nitrogen,
no sand.
stuff,
Sand.
right?
Sand.
You know what?
So you break all that down, you can't.
Dirt.
I thought about something like related to that.
What?
The very beginning of time, the sperm and the egg, see, they mix and they form a baby.
Yeah.
So that's chemical reaction. Maybe from there, it breaks down like step by step until there's a skin right here, there's a head, there's a hand. So it's chemical
Yeah.
reaction or whatever. Maybe.
That's the.
So they say we're,
Yeah, just like what we eat,
uh,
and we observe the different nutrition, and then we grow our hair, and we grow
yeah, maybe
people.
the nutrients make hair,
Yeah, different
that would be, don't you think?
It's called coagulation reaction.
If you just take chemicals together and mix them together, and do you get some hair? I mean, like, seems like that's what happens to,
That's right. That's
well,
right.
that's what happens to you guys. Doesn't happen to me anymore.
But anyways, time is because time consuming again, and I'll just go through quick the questions. All right, make sure you know the definition already, the critical attribute, chemical reaction, and some non-critical attributes, so that you can be sure of what really is, And I was going to go through some individual questions as kind of a quiz. But, thank you very much. As we go through the discussion, I noticed that some of you they're getting there, But overall, you guys are doing good. So thank you very much. Thank you for coming, and keep your notes with you. Study. Next time we're gonna go through some more examples, right? Because we're a little bit like. But thank you very much. Thank you.
Bye.